Okay, so thanks a lot for this opportunity. Myself, I'm Isaac Henderson, so I'm based in Stuttgart, Germany, and I'm working for Fraunhofer IAO, the team of identity management. And yeah, so I would like to present today our paper on trust implementation model for cross-domain decentralized identity ecosystems. We also present an architecture followed by a use case and also the implementation of what we have done and also the open source code available for the community. Great. So the agenda goes like this. So it starts with the motivation and then an introduction and followed by the existing initiatives and also the literature research. And then we present the use case, which is a Gaia X scenario, which we are presenting for this paper. And then we present our architecture of train and how this can be used in Gaia X Federation services, and also the unified signature and verification model. This is also the part which we present here, and then we end with an outlook and conclusion of the chapter. Okay, so why did we write this paper? So as we all know, the decentralized identity ecosystem is evolving, and also it's currently being put into practice, especially in the form of different the EPSI blockchain, or EU digital wallet, which is on the way actually, and which is planned to be implemented soon, and also to be protection to citizens by end of 26 or 27. And there are also other non-natural person identities like IX, for example, initiatives or Catena X initiatives in Europe, which provides or which claims to provide these sovereign data sharing ecosystems, for example. And so I think you might be aware of this. If not, I'd be happy to also explain in detail later of the session. But one problem as we develop different architecture and specifications, one of the major problem what we face is interoperability in decentralized ecosystems, and which is also a roadblock for affecting the adoptions in many use cases or many pilot projects. So in this paper, we introduce an trust implementation model, which enable cross-border, cross-organization for credential interoperability using DNS. So that's what we present in this paper, and also we provide also a novel unified signature and verification system using verifiable credential, and how this can be used for integration in different trust list use cases and also with other trust domains actually. So in literature research, and also we looked onto existing initiatives, especially almost 10 different initiatives starting from Gaia X. We also looked into EPSI and the OpenID Federation, and also the LEI one, the legal entity identifier from GLIVE, and EADAS Trust List version 1, and also other different things like TrustEdit and different approaches. So one thing what we came across is all these different approaches are specific to certain trust domains, and they are not generic, and they are mostly focused on certain specific use cases, and they are not interoperable beyond their ecosystem or scope, for example. And these things we also faced, example, in the COVID initiatives, for example, right? So there were different COVID certificates issued across different continents, but they were not interoperable when you just cross borders. So that's what we are trying to see in this approach out in this paper. So when we found out actually, so most approaches are specific to certain credential formats or certificates, for example, X509 certificates, and some might use DITs or blockchain, for example, but they cannot speak to each other, right? And one of the approach, for example, EADAS one, which is quietly in Europe, it's in practice and also being used for a couple of years. But all the other systems are just maturing and in the form of demonstrators or pilots or POCs actually. So those are the current status of the existing research in this field. So why did we take the scenario of Gaia X actually? So Gaia X claims to be providing a decentral, federated, and interoperable autonomous ecosystems, right? So that's how the Gaia X claims to provide this trust framework. And in Gaia X allows actually not only just to have a certain trust domain and control them, but also to build different federations in it. So for example, this can be a company or an data space, for example, and they can have their own trust framework, and Gaia X is controlling the trust plane, for example. So they created this 3-layer approach of trust, management, and usage plane, based on the use cases or based on this, different scenarios, for example, for education, for automotive, and for agriculture, for example. So they have different ecosystems, and also how do these ecosystems speak together, so that is the current challenge. And in Gaia-X, currently it is done using a Gaia-X trust framework and a trust registry, which is managed centralized actually. And or it's also managed by a X509 certificate currently, and it's being used in practice at this point of time. But which again puts them to a centralized approach, right? So, and which is not quite decentral how it claims to be. So that's what we are trying to, we took this use case and we see how our implementation can be used here. And so that's why we took a part of a project which is called the Gaia-X Federation Services, which is a German government-funded project for building tools for federations, actually. And this is open source under Eclipse Foundation. And so this source code can be found here, actually. So they have a lot of different tools. And these tools enable how to build a federation and how to operate a federations. So, and now we are going to talk about our infrastructure, which is called Train, our trust management infrastructure. And what does Train do? So Train establishes the trust building using with the trust frameworks, for example, across different trust frameworks, by allowing individual, the trust anchors to define their own trust anchors or authorities of a root of trust. So for this approach, actually, we use the existing DNS technology, because DNS is a quite old or useful technology, which is already decentralized and, adopted by different organizations. And also there are around 350 million domains used in practice. And DNS also offers a chain of trust using the DNSSEC methodology, where this chain of trust is being also verified. So how do we come up with this approach? So this project provides also actually, and in the next slide, we'll be seeing how this can be used for trust purpose, actually. And this was initially developed in 2016 to 2019 in a EU project called Lightest for X509 certificates, how to develop individual or independent PKI certificate authorities and how organizations can maintain it. But from 2020, we started an NGI SF Lab project where we used this approach, or where we adopted this approach, and how this can be used for verifiable credentials, and did approaches to verify, because there was a problem, because there was multiple decentralized identifiers growing, and you don't know which identifier to trust, right? Or which identifier is trustworthy. And because anyone can create a decentralized identifier, and at the end of the day, you might not know which one is trustworthy. So that's where we created in 2020 this project. And then further, we also evolved in the COVID certificate. We also created a use case for GCCN project funded by Linux Foundation for Public Health. And then we also adopted current practices in also a couple of industry projects with T-Systems and Huawei, and also in one of the German funded project called Once, actually, which is a showcase project from German government. And it's also currently being planned to use also in the UNDP use case for health use case, actually. So how do we establish Train in GXFX? So Train is something based on the DNS, and it's quite decentralized and flexible, because every domain owner can create their own domain, and they can operate their own records at their end, and they can also anchor different trust domains into it. So same problem comes with also the Gaia-X model, right? So the Gaia-X model requires a decentralized, at the same time flexible, and also scalable. So all these things are addressed by DNS. So that's why we thought there might be a good approach to showcase how this can be used for this use case scenario. And what are the challenges existing in the current Gaia-X scenario? So how do we manage the trusted entities or federation, or participants in a decentralized way? Because currently there are like centralized authorities or gatekeepers, as I mentioned, the Gaia-X trust registries, which involves like a gatekeeper to enroll decentralized ecosystems of federations into the system. And next one is, how do we verify that this credential is a trusted or not? Because each and every federations can issue different credentials and different schemas and different attributes. And how do you know that this is coming from a trusted authority? And next one is, how do we establish interoperability across federations? Because it's a main problem also can come, the credential issued by one federation or one ecosystem might not be accepted by the next one. Or how do we do this translations, and so those are the different things, because there are different trust anchors available currently. The ETSI has its own blockchain trust anchor. The IAO uses its own trusted issuer registry. And then there are also other sovereign defined trust anchors like TID-based one or X509-based one. So how do we establish an interop approach together this one? So these are the challenges still existing, and these are the things which we are trying to address using Train architecture. So this is a Train architecture which we provide. So there are three main components involved in this ecosystem. One is the DNS zone manager, which is a DNS zone file which can be operated by any domain owner. And this is the trust framework manager, or the entity which is responsible for enrolling entities into the trust list. And there is also a validator, TTV, the Train Trust Validator, which can be also deployed as cloud instance, and it enables the trustworthiness of the credentials. And here, actually, in DNS, we use the two records for hosting the trust list. So one is the URI record we use for establishing a link, in the of the trust list. Actually, the trust lists are anchored in this URI record, and the PTR record is used to point different trust lists, because in Train, not every federation or every domain owner needs to have their own trust list, but they also can trust the other person using this pointer record. So that's where we use these two existing records to enable this approach. And how does it sit in this, the self-sovereign or decentralized ecosystem, for example? So as we all know, this triangle diagram, the issuer, holder, and verifier. So the TTV is used in the verifier or a service provider to validate the request the holder is asking. For example, when the verifier is fetching some credential, for example, to validate, then it also needs to verify whether this is coming from a trusted issuer. So that is being checked by this TTV. And the Trust Framework Authority, or the TFM, is responsible for enrolling or maintaining this trust list. And these federations can be decentralized, and any domain owner can have their Trust Framework component up and running, and they can do their trust enrollment. And so this is how the approach looks like. So how different domains, for example, and how our records which we are using. So as I mentioned, the two different pointers we are using, the pointer records and URI records. And this is a scheme format which we are using to create pointer records, _scheme._trust, and then the trust framework name. So here it is called compliance.gax, and here it is called notary, and here it is called an organization. So here, for example, the trust chain is established by the compliance trusting a notary, and the notary further trust an organization. So, but each will be hosting their own trust list and their own end, actually. And so that is how it's being done. And by which you provide a decentralized model enabling each and every organization to maintain their trusted entities, but at the same time also enable links actually across each other by providing a sovereign and also a decentralized approach for operating the trust list. So let's see how our trust list looks like. So we follow this trust list approach of ETSI format, actually from the IAO one. We were inspired. And this enables also the trust list to be created in XML and JSON formats, where in the implementation which we developed, it supports two different formats. And the TSP, this is a trust service provider service. So each service provider, for example, an automotive federation, can have different services. So one, for example, communication related things, and other for the data storage and data related stuff. So they can have different services, and these things can be mapped with an identifier, because this identifier will be further mapped in the credential. And so you can have different things. Actually, here you also have which rights they have and which credential types they are allowed to issue, and things like that you can mention over here. And how do we integrate with credentials? So this is an example of how we integrated with a VC or verifiable credential data model. So we use the terms of use attribute, and then we include the trust scheme where it belongs, actually. So this is a normal VC credential. So this is an organized credential issued by Fraunhofer, for example, but as a participant credential with this ID. And this ID, the terms of use tells, where the trust list is located. For example, the notary trust list is being issued by this person, and we need to know whether this issuer is over there in this trust list, So that's what it will verify the TTV. And we use this approach actually to further anchor the different trust schemes or different trust lists in these approaches. And in the TTV or a trained validator side, we have the issuer details. So the issuer details and then the trust scheme pointers are being fetched, and the API request is made to the trust validator. It then goes to the corresponding DNS and fetches the trust list and then checks whether this issuer is present and whether this credential is trustworthy or not, by which we can have more trustworthy credential and also real-time check based on the trustworthiness. And one of the most important policies also is we have a trust policy. So each and every verifier or validator can have their own policies implemented and also adopted based on in real time, based on the usage. For example, you can include different level of assurances and not only just checking the issuer attribute, but also check some other schema details or, the different attributes.
Isaac.
Yeah.
Isaac, sorry to interrupt. You've pretty much run out of time. Do you want to sort of skip right to the end?
Okay, perfect. Yeah, sorry. Yeah, okay. Yeah, actually, I'm just coming to an end. So this is the unified trust list model, which we presented here. So where we wrap the trust list in a form of VC, and then which is mapped to a DID document. So then by which you have like a unified signature model of mapping different trust lists into this VC. And currently, we also integrated with different GAIAX components, actually, with Trust Services API and Organization Credential Manager and Notarization Services. And this is, so the outlook is, so this provides a more interoperable and decentralized approach of managing trust. And also this unified signature model where this trust list in a form of VC mapped provides a more flexible and unified approach and also easily able to map and wrap the trust list and in a quite flexible way. So currently we are planning into adoption and also more standardization work, which we are going on. So that's where we are working in, and also we are parallelly looking into the ENS, what are the other alternatives, how to work on that, and also we are also planning to include the support of OpenID Federation and EPSI Trusted Issuer Registry as a part of further implementation. And thank you. So that you can find the codes in this following link, and yeah, I'm happy to answer questions. Thanks a lot. Sorry for the delay. Yeah.
Excellent. Thank you, Isaac.